We've got Kelly Thompson here from DWR, State Engineer's Office, and he's going to be talking about historic consumptive use, StatesEU, least fallow tool, all that kind of good stuff. So I'll hand it off to Kelly.
Yeah, I'm going to talk a little bit about the nexus between our ET evapotranspiration data that we've been kind of working on in-house and how you can use it with the CDSS tools. And again, it's this kind of statewide ASCE standardized based ET data that we're using with grid points so that we can look at it at field locations rather than just structure locations. So I want to talk about the importance of those components, but then how we use it in StatesEU and in the least fallow tool. But I will give you a little disclaimer, advance warning. This is where we're heading. I thought it'd be really nice to tell the group, tell this, all of you who are really the CDSS users, where we're headed. The data's there, the tools are there, but I'll talk about how we are having the data, for example, peer reviewed, and these tools are still kind of our prototype tools. And so none of this is available quite yet to you. And so I just want to tell you that up front, because there are some really nice snowboards if you want to go look at snowboards. But just to be clear, but I did want to talk more about where we're going rather than where we've been, and so that's what this is sort of about. And again, this is about ET to start out with our ET data. So thinking that, again, ET means evapotranspiration, which is, for many of us, leading to historic consumptive use analysis. Thinking about how much water was used historically. But so how, about 3 score years ago, they started working on Blaney Criddle. And all of us have used it, I use it. But it is, it's based on temperature, and really it uses all this calibration in its crop coefficient. But that calibration really is based on the location that crop coefficient was developed. It really is, because it cannot, only using temperature, it can't handle changes in solar, wind, humidity as you go up in elevation, different locations. So, really oops, I'm sorry. I should get my hand off that. I really do believe in localized calibrations. We talk about that a lot, where you use ASC standardized at one single place, a NOAA station, and develop it there. But really, those crop coefficients are not transferable to other elevations, in particular, other locations. There are elevation corrections that POCOP and others have used, but really those are still also site-specific. That was developed in Wyoming. I look at those elevation corrections, what they would need to be in Colorado, and they're different. They get higher and higher as the further south you go. And so that is what we have used, but really, what should we be using? I guess I'd throw out there the ASC standardized DT equation that was really published in 2005, again here in Manual 70, the new version in 2016. But it has been recommended by ASCE and our Colorado ET committees that we've, kind of ad hoc committees we've had as the standard method to estimate ET. And for me, why I have really gotten into this is also in the Arkansas Basin. In that litigation, Kansas v. Colorado, they really did say that we should use this type of method for ET. And so that's really the reason why we're starting to look at this on a basin-wide scale. It is based on a standardization of Penman-Monteith, and it's physically based. So if you have good data, you should get the right answer. You don't have to calibrate it with something else. It gives you ET. But it does require more than temperature. It requires relative humidity or vapor pressure, solar and wind data. So it takes a lot more data. And it does calculate a reference ET for grass of alfalfa. And our big part with the Colorado ET committee is that if you use the alfalfa reference, so the ETRS, if you develop one set of crop coefficients for alfalfa reference, they should be transferable throughout elevation and location. And so that's another part of this. ET with ASC standardized as reference ET times a crop coefficient. We do need a good representative set of crop coefficients for the state of Colorado. And so our immediate needs, why we really got into this in-house, started out with ArcDSS, this Arkansas Decision Support System. And for that, we do need a basin-wide set going up into the mountains using ASC standardized. And we need it usable with StatesEU. So that's one thing. But more recently, we do have this HB 131248 They're the ATM pilot projects, least fallow pilot projects. And so right now we have criterion guidelines that say how we calculate the ET for that. That's Blaney-Criddle with TR21 coefficients. And that was set sort of thinking of the lower Arkansas Basin, but to be a certain percent conservative. But as I was mentioning, as you go up in altitude, Blaney-Criddle gets worse, well, gets further and further off. And so it greatly does underestimate ET at high elevations. And so we did, get some interest at higher elevations for those projects. And in front of the CWCB board, we have direction to evaluate new criteria that would be equally conservative at all elevations, to be fair at higher elevations. And so that's number two. That needs a statewide data set. ASC standardized would enable us to be the same fairness at all elevations. And then we are in-house looking at new guidelines for wetland ET and water evaporation, and we're looking at methods that use ASC standardized for that. But ASC standardized is tough, right? I don't know. It does really require, and I can't stress this enough, a thorough QC of the data. One of the most common things we do in our QC is to recalibrate the solar data. That recalibration can send the ET, cause differences by 20% in the resulting evaporation. So it really is it does need a lot of thorough look at the data. We are proposing doing aridity corrections. These two pictures, ASC standardized is set up for a station sitting over nice green grass or something very nice and green like alfalfa. But obviously the station on the right, which is the Avondale station, where it used to be, is not sitting over green grass. And that ET is going to be 5 inches higher than it would be if it was over or more over green grass. So we need aridity corrections. We need a way to simulate data when there's not coagmet. Coagmet stations or Northern Water Conservancy District stations came in the 2000s. Now, on the West Slope, we just got 10 new stations last year. And so we need a way to simulate data when we didn't have that data. And as I'm talking about field location versus structure location, we need a way to get it out beyond the climate station. And so that's kind of tough for everybody to do. Everybody, I think, in the room I would trust you doing, but you're probably going to have a different way of doing it. And so I think that's why we really, or maybe we came up with sort of a plan that we're going to develop some of these sets at Division of Water Resources. So we are developing these basin-wide, statewide sets that are sort of pre-prepared, standardized, peer-reviewed, and ready to use. And so we're, first thinking at all the primary weather stations, NOAA and coagmet northern stations, to QA, QC, correct, fill the coagmet data, correct the NOAA data, and then do these simulations, calibrations to fill in, 1950 to current, or we actually have gone back to 1910. We might redo that for our sets. Number two is establish a set of representative crop coefficients, as I was saying. And so we should be able to have one good set that represents the crops of Colorado. Well, we do have two new ones in our draft set from the Rocky Ford lysimeters, and we'll have a few more from the Rocky Ford lysimeters that we think might be more appropriate for Colorado than coefficients that were developed in Texas or Idaho or California. So, and these tools that can use data, translate it to these grid points. And then again, like I was saying, have this peer reviewed. And so right now underway is the review of the ArcDSS data. So the data for the Arkansas Basin is being reviewed as we speak. And then we do have a grant to review the statewide set that should be initiated in the next month or so. And so this is the report that went out on the Arkansas Basin. It is being reviewed right now by Tom Lay. Wilson's going to look at it. We are going to have a couple other consultants look at our statewide set, and we would love to have lots of input from everybody in the room on the processes and the data. But so again, this is Division 2. This is again station data, so not grid data but station data. When we get it all nice, this is kind of the end product of ETR, or reference ET versus elevation. Things start to look pretty nice when we make all these corrections. You can see here, I shouldn't use the pointer, but everything really does fall except where you have some oddities. Walsh and Springfield, they're almost in Texas. They're a little hotter, but everything else is pretty much on this R squared of 0.91 line. But we do have more than just Arkansas data. Here's Division 1. You can see like the Republican Basin stations are a little hotter, and the ones near Pawnee Buttes are a little hotter. But then Georgetown, Allens Park, Estes Park a little colder, while South Park is a little hotter because it's real windy and sunny there. West Slope, a lot more scatter. But really, if you look at these, almost all of this is oriented south to north. So Toyac is the very southwest corner of the state, the Ute Mountain Ute. A lot of these are Durango on top, but then on the bottom it's Baggs, Wyoming. We do have that station in there. Steamboat, Crested Butte. But the West Slope data is a lot more variable, and we're still getting West Slope and Division 1 reviewed. If you could read that. But now to talk, ET, those are stations. So those are all the primary climate stations, NOAA and COAGMET and Northern. But it can change significantly, ET can change significantly from those station locations up into a point. And admittedly for the South Platte Plains, for the lower Arkansas Basin, we do have a good distribution of weather stations, not a lot of elevation change. Maybe we can stay with station data. But as you get into the mountains, especially West Slope, ET can be a lot different. Here is the southwest corner of Division 2. I'm going to use this, I apologize. So here's Walsenburg and Trinidad. So there, the Arkansas Basin's down here at 5,000, 4,000, 5,000 feet. They are up at 6,000 feet. So we do have two weather stations at 6,000 feet. But we have 14,000 foot peaks right here. So the top of our systems come up here to 8,000, 9,000 feet. Right. So in StatesEU, what you could use, now, all sorts of distributions of your weather stations, but you're going to have Walsenburg and Trinidad at 6,000 feet trying to estimate ET at 8,000 feet. It's not going to work. ET is 20, 30, 40% lower at 8,000 feet than 6,000 feet. And so in these cases where we have big elevation changes and we don't have climate stations all over the place, we need to start to think about translating this out to grid and to acknowledge elevation changes. So that's this whole grid thing. I'm sorry, I put all my titles at the very top, but this is, I started to lay out all the equations we're using. These are the equations, and here's some exclamation, but really the gist is all these equations are in the reports that are being peer reviewed, and they'll be out there for you to review. But I guess to talk about it, really what we're using for these grid points is a mix of the station data, where really the station data is dominating, but we're also using GridMet data. So that's kind of this gridded data that you can get online. And so GridMet, a new little thing to talk about, it's produced by the University of Idaho. You can get to it at this webpage. And Desert Research Institute also really promotes it, uses it. Desert DRI is using it with the Bureau of Reclamation to estimate ET point blank throughout the upper Colorado River Basin states for their project. And so they're using it really directly. I'll be honest, between us, I look at it and I believe station data is more accurate than this GridMet data for ET and for the individual components, solar, wind. But as we go out up into the mountains, the solar data is really useful to us to say where it gets cloudier. The wind data as we got onto the plains is useful to us to say where it gets windier out on the plains. And so we are using primarily those two components, the solar and the wind, from GridMet. And we're also using their grid. And so that's about 17,500 grid points for Colorado. And so those are this many decimal degrees latitude, longitude that grid is on. But so that's about every 2.5 miles we have a grid point. And so that goes from 79, but we are running it back to 1950, so doing this all daily data, 1950 to 2018. I do, for these figures I'm going to show you, I do run that for every grid point, those 17,500 points. That produces in a binary file about 15 gigs of data. Because of that, that's kind of influencing the direction we're going at the moment. Like that right now is too much to put in Hyderbase. we believe. But we're still developing how we're going to store this data. But that's why we have this tool that's kind of doing it on the fly. Rather than storing 15 gigs of data, we're calculating these grids on the fly for it to use in the tools. So I'm going to, these are the grid points. So that's the 17,500 grid points across Colorado. This is just showing within those points the elevations that are in there. We did take the elevations from the DEMs, although they're in there. They were more accurate than what was in there. But so I'm just going to flip through a bunch of rasters. I probably have way too many figures here, but these are characterizing the average. So we did run this daily, 1950 to 2018 currently. But these are averages just for this 2000 to 2018 period. And the dots on here are the NOAA stations and the coagulate and the northern stations. So you'll see where those are. But this is kind of the judge of how our method is doing. I just wanted to throw these out there that these more than anything show how it's working, up into the mountains and other ways. So I think they're kind of neat to look at. So this is minimum temperature. So again, the hot is the kind of orangey color, but then the blue is the cold. So if you can can kind of see, the ridge of the mountains coming down. So that's minimum temperature, maximum temperature, vapor pressure. So it is more humid out on the plains. Solar, which you see division 3 down here, gets pretty hot. That's kind of hard to interpret, but this is clear sky envelope minus solar, which is something we've really been struggling with. So this is the cloudiness, and the colors are getting kind of weird here, but you can see how it's a lot cloudier over the mountains, and a little cloudier maybe in division 1 than division 2, obviously. The southeast corner is pretty hot. Division 3 and down by Cortez is showing up less cloudy, and so that's in. So all of these data components, wind, here's higher wind out on the plains, go into the ET. So this is the grid of reference ET for those 17,500 points. And so that's ranging from 34 inches in the mountains down to 92 inches down here by Walsh. Evaporation, they're, FAO 56, that document from 1998 spelled out shallow water evaporation can be calculated by 1.05 times grass reference ET. So that's this new estimate of water evaporation, again going from 29 inches or so to 67 inches. This is annual number, without ice cover considerations, et cetera. But then you can run all the crops. So this is using our current crop coefficient set that's spelled out in that report that will be very, available to you within a few weeks, I hope. We've got alfalfa going, 0 to 56. These are all going to look a lot different, but the ranges are different. Alfalfa's going 0 inches to 56 inches. Grass hay, it's calculating 0 inches on top of the 14ers, but going to 45 inches near Springfield. Corn, 0 to 36. Wetlands, we have a way that we're estimating cattail wetlands. Anyways, so that's just showing how the data is working on these grids. But so how do you use it? How do we get it, sort of into a tool or into a data? So for StatesEU, our current prototype thought is this little companion tool that will work with StatesEU. It is a prototype, an initial solution for getting this data for us to use in ArcDSS. I think we're going to really welcome a lot of input from you and from ourselves internally if this is the way we go. But how it works is you already set up your StatesEU run, so that has, an RCU and a structure and a crop file, but it reads those files directly, so it just goes into those files, reads those, that, you can build those with StatesEU Wizard, but obviously, we do this all with TS Tool. Anything more than one structure, you probably want to use TS Tool to build those. StateDMI, TS Tool and StateDMI. But then so that's setting up the StatesEU input files. It goes in and reads them, and then it does use the Hydra-based REST service to get a better location, a structure location than what those StatesEU files have. But then it spits out IWR. So with an IWR file, which is called an RCR file in StatesEU lingo, that can be read directly by StatesEU. And so, and that it currently is built in MATLAB, which I often use. So you do have to install a free library that's a little bit painful, but because of that, we're hoping to convert it to C, or maybe the Fortran of the, integrate it more directly into StatesEU. But hopefully at some point we can convert that to a little better language. It does currently come with 2 of the grid data files that has that grid data in it. But obviously Wilson's going to look at it here pretty soon, but we're waiting the data review of all the data before we release it. And so, so getting to the examples to use it. So this is how it's going to, how you kind of would use it in StatesEU. I talk a lot about Arkansas Basin. I think Brian said nobody cares about, no, he didn't say, nobody cares about the Arkansas Basin. No, sorry, Randy. No. But so South Platte, I don't know too much about South Platte ditches. So what could be more representative, than the South Platte ditch? I don't know. So I just picked the South Platte ditch right on the edge of District 64. And again, you can see they do have, pretty good distribution of weather stations. Maybe gridded data isn't all that key here. But it is, 10, 15 miles from these other weather stations. This is the South Platte ditch. So this is Sterling, Fort Morgan, Brush. So just looking at that as an example. So this is with the wizard. So using the StatesEU wizard, one structure, easy. So I didn't know quite how to show this without it being live, but okay. You open StatesEU, file wizard. Here's your wizard opening, and pick a structure scenario. Go down here, pick your ditch, name South. Okay, picking the South Platte ditch. So this is the wizard again. If you've used the StatesEU wizard. Again, keeping going. So you collect, it automatically pulls in the crops for the most current crops that are in Hyderbase. There are a set of crops in Hyderbase. That is a little different than the least fallow tool, which pulls in that time series of crops. But to start out with, you're going to get one crop distribution. Select your climate station. It does need a dummy station in there just to use. We're going to say 1950 to 2018. Hit create new scenario. Yay! It adds some a canal efficiency of 80%, 45% flood irrigation. So obviously, then you would go into the StatesEU files, and for your own project, adapt those to what you need if you know your canal efficiency, etc. So yeah, in the IPY file, let's say it produced. So these are all StatesEU wizard files. It produced all these files, but obviously, like the IPY file. I guess that's the irrigation practice file. You could go in and maybe change the canal efficiency, et cetera, et cetera. But then, okay, your StatesEU input files are ready. Then you can just run this little companion tool. This is what it looks like at the moment with these 2 little data files. Hit that, it says it's running. It asks you for the RCU file. So that in StatesEU, everything's referenced with the same base name. It's going out to find that RCU file with the base name. Goes into the RCU file to look at what all the names are, where they're at. It says, I need better structure locations than what you gave me. Can I use REST services? So yes. Sorry, I put a little comment. This can be slow. It's very, actually it's pretty fast typically, but if you're running 800 of these, it can take a little while. Like on a full model, if you run the South Platte model through this. And so now this companion tool spit out 3 files. This is a structure file, which just gives us a better latitude, longitude UTM. Right? If you actually look in StatesEU, that IPY file only has 2 decimal digits on a latitude, and it doesn't have longitude, so it needs latitude and longitude, and gets UTM to be a little more exact. But this is the headgate location. It went and got from the REST services. From Hyderbase, it got the headgate location. If you wanted to, put in your irrigated area, you could alter that then here, and then rerun this. But so that's structure locations. It also, you see, put out the RCR and a log file. So this is the RCR. So again, this is not PET, not potential, but this is irrigation and water requirement after it subtracts the affected precip. So this is IWR by structure. Then this can just be fed directly to StatesEU. So yeah, it puts the RCR file name in the state. This is the RCU file name for file for StatesEU that defines where all the files are, what their names are. It puts that in there. Great, go to StatesEU, excuse me. I couldn't figure out how to screen capture with the things, but you would pull the little rundown, hit run simulation, and then here's the output file. Here's the, so StatesEU produces a whole series of output files, all these output files. OBC, the BD1 is the binary file that TS Tool can really read more readily. The DWB, the water budget file, has a lot of what you want to look at. So this is just a little pull out of that water budget. So yeah, irrigation water requirement 4788, which is exactly the number that we fed to it with that RCR file. And then it did the water supply limited consumptive use analysis to come up with historic CU. So that was this one example, that South Platte ditch on the South Platte. I just put that really quick into the least fallow, and I think I was getting way too many slides, so I won't go much into the least fallow tool. But this would be just that same exact location ditch in the least fallow tool. So if you haven't seen the least fallow tool, you've just have some pull downs to select things, and it builds an input data page. So that's what this is doing. So Division 1, this ASE standardized set would be, these all have pull downs. The 1950 to current, and then you pull down your ditch. It's got a listing of all the ditches in the South Platte. So you'd pick your South Platte ditch, and then for this tool now, so this is the new version 8 of TS Tool, or of least fallow tool. And then there's a selection to use grid data instead of, normally you could pick the closest station to irrigated area or a station, use grid data. It picks the crop distribution, so it's pulling stuff out of the South Platte model. So it's going to pick all the crops out of the South Platte model. You can do a Glover analysis here if you're going to do lagging stream depletions. And if you want to add in the irrigated acreage centroid instead of pulling the headgate location, this is going to find the nearest grid point to your headgate. If you want to put the centroid of your irrigated acres, you put it in there. And run it. All you have to do then, it runs the input. All you have to do is put in your acres. So I just, to match the other one, I put in the ditch acres. All the rest of the data comes out of the SPDSS files. So put in acres, hit run analysis, and boom, there's all your results. And so if you've seen the real purpose of the least fallow tool wasn't to do anything magical, but just to streamline, simplify, pick 3, 4, 5 options, hit run, there's your results. Here's all the results you need for a pilot project or other, so this, I don't want to get into the numbers, but yeah, it has consumptive use, depletion, stream depletions, depletion factors, et cetera, in all the different tables. Anyway, just how it looks in the least fallow tool. But wanted to show just a little bit more. StatesEU example number 2, maybe this is a little bit much, but these 4 ditches that I was showing in the southwest corner of the Arkansas Basin, how would Walsenburg compare to these ditches at the top? Trinidad compared to the top of near Stonewall. So again, in this I already set up the file. So here's my StatesEU input files already set up. There's 4, so there I have the 4 structures. I did put in, the Walsenburg ditch, Stonewall ditch, south side by Trinidad, Russell and Stores at the top of the purgatory. But I did just use the same acreage and diversions just to make it an equal comparison. But so here's the crops. Here's the crops in your CDS file. Okay, so now run the tool, ask you whether it's named. Okay. Pick yes from REST services. This is the structure locations. And here's my IWR file. Great. Here's the log file. Sorry, just wanted to show you. It does show you a lot of the options used from the log file. Run StatesEU. And here's the results out of that. This is out of the WSL file. I just threw up with the results. And so, yeah, so it shows in this little test example, 479. And this is supply limited, so it's not just irrigation water requirement, but 479 down on Walsenburg, but 338 up at the top of the Cucharas. So 338 at the Stonewall ditch. Down by Trinidad, 485. So this is acre feet, average acre feet of CU. Up at the top, the Russell and Stores ditch, the top of the Purgatory, 304. So for that 304, 480, 45. So that's a 40% drop from the climate station location to the top of the system. So the ET is 40% different. If you didn't use some way to translate that elevations, you would have the exact same ET for 8,000 foot and 6,000 foot. So that's just the point of it for ArcDSS, is we don't want 60 inches of ET at the top of Levita Pass, So that's the point of our. Oh, and this is why this thing looked really like a fifth grader's presentation. I apologize, but yeah. But are there any questions? Sorry if I went a little bit longer than my slot, but the question was in that last example where we're using the grid ET, and yeah, so that's using that little companion tool. The companion tool says, where is the location of my structure and where's the grid point, and it does that translation to the grid point. So yeah, I did run it with standard TR21 coefficients, but I didn't put those results up there. I apologize, because for the Arkansas Basin. We don't really, for the South Platte, we do have regional coefficients from SPDSS. I think for all of our water right cases, we've said you shouldn't use a regional coefficient, you should use a local coefficient. For the Arkansas Basin, we don't even have regional coefficients developed. You could use, like we do for HB 1248, we do use Blaney-Criddle TR21, but I wouldn't portray that that's right. But yeah, these ET numbers are probably higher at Walsenburg than Blaney-Criddle TR21. Probably, probably higher. Yeah, for wetland, we do have a little different, we do have some guidelines that we're developing on the wetlands that describe where we're coming to with this. Rick Allen put out a couple papers that show wetland ET using ASC standardized for cattails. And so this is a big, tall cattail bulrush type wetland that was characterized. Those were, he did it through lysimeter studies up in, I believe, in Idaho. And so that is a crop coefficient that ranges from 0.3 up to 1.1, I believe, during the summer for a large stand of cattails. He also has a number for a narrow stand of cattails. So if you just have this, I think he says a 6 meter wide stand of cattails, it has a lot higher ET rate because of the wind, the clothesline effect on it. So for us, we have a number for that large width and the narrow width, and a recommendation to interpolate between those two based on how wide your wetlands are. But yeah, that is for cattails. We also recommend potentially in our crop coefficients, I'm using a grass hay number, which is considering that it's a grass hay that's cut once, but we do have a meadow grass number in there that we would say is like a wet meadow that isn't cut. And that is really lining up more with those like with the Denver high water, South Platte grass numbers, because those are pretty high numbers. But we're portraying that as a grass that is not cut. We are also portraying that potentially as a high altitude wetland, because cattails are not really supposed to grow above 9,000 foot, and so they're grass dominated. So we're saying for above 9,000 foot, that's not cattails, use our meadowgrass number in that recommendation. But yes, I know there's all sorts of different types of wetlands that we potentially would need to think about, or you would need to think about. Sorry, I didn't repeat that was a question on what type of wetlands those numbers were for. But the report, the first peer review was supposed to be completed by now. I think by the end of February, we'll be pretty solid on that peer review, and we're definitely going to convey that to Kansas because we work with Kansas on ArcDSS. We're thinking the 1st of March. So I think that report for the Arkansas Basin will be ready the 1st of March. The peer review for the statewide study is starting mid-March, and we'll probably go to the mid-June. And so the statewide report and or numbers probably won't be ready till June or July. The companion tool, that's what we're going to use initially to pull the numbers for the StatesEU run for ArcDSS. So I'm wondering if we can put that out there 1st of March also. we might want to see with our internal folks if if it's gonna go with the data that quickly. But like I said, we might have some better solutions that could be put out there as this is a prototype, use at discretion, and it's not in a perfect language. It's in this thing. You have to install these MATLAB libraries just like for the least fallow tool. But I'm hoping to put that out in March too. But we might see on that too. Yeah. I mean, the concept for this is all the data we're producing daily data 1950 to 2018 of the full solar, wind, humidity data, and then using ASC standardized to do the calculation. So it's not mixing Blaney-Criddle with ASC standard like I think we have done a lot in the past. And so with that, then we only need one set of crop coefficients. And Rick Allen, I don't know, in a number of ET references really put out there, they recommend, instead of using mixed methods, using a temperature method to, they really recommend using full ASC standardized for the entire period, because then your stuff's parameterized. You can see, do my parameters make sense? Does the solar make sense back in time? Does the temperature make sense and the humidity make sense back in time? But then, you can use the temperature for your growing season parameters. But then, then you only need one set of crop coefficients. And so I think we're really going off of Rick Allen's recommendations that we go to all the data being in the world of ASC standardized. And yeah.
Thank you, Kelly.